Rocket jumping. The action of using a rocket launcher to propel yourself in any given direction. Rocket jumping had its beginnings in id Software's Quake, which was released in 1996. Other variations have come, like sticky jumping, grenade jumping, or whatever this thing is jumping. But there is one game that is iconic for rocket jumping. Team Fortress 2, in particular with the soldier, which is what I want to look at today. Now in real life, rocket jumping isn't very practical, because when you shoot a rocket at your feet, you tend to just, well, you know. But when the soldier does it, he flies through the air. But why? Well, the easy answer is that it's a video game, and generally speaking, it's more fun to fly through the air instead of dying. But what if we applied real-life physics to this video game? How then could we explain the phenomenon of him not being torn apart by the rocket explosion? Well, first we need to know exactly what we're dealing with here. We need to answer the question of how many newtons of force is the soldier withstanding when he rocket jumps. Now, before I get into the math, I need to give credit where credit is due. My friend James, or CD-ROM Overwatch on Twitch, link in the description below, helped me with the math for this part. So, thanks man, I really couldn't have done it without you. To figure out the force that the soldier experiences from the rocket, we are going to need two formulas. F total equals mass times gravity times y minus 1 for the total force, and force of rocket equals mass times gravity plus F total for the force of the rocket. When you rocket jump in-game, you first jump and then shoot a rocket from under your feet. So first we want to know the total height of a rocket jump. The maximum height of a rocket jump is 576 hammer units. Quickly, before I move on, I'll explain what a hammer unit is. A hammer unit is the measurement of distance that the source engine uses, which is the game engine TF2 runs on. A hammer unit is equal to 1.905 centimeters. Since the total height of a rocket jump includes both the height of the jump and the height that the rocket explosion propels you to, we want to figure out the height of these two factors separately, since we are only looking for the force that the rocket explosion creates. A standard jump is 50 hammer units. So, if we subtract that from the total height of the rocket jump, we'll get the height of just the rocket explosion, which is 526 hammer units. Next, we need the soldier's weight, which is 90 kilograms. Now that we have everything, let's begin the equation. First, let's convert the height of the rocket explosion into meters. Doing this, we get 10.026 meters. Then we can plug everything into the first equation to get the total amount of force acting upon the soldier. From there we get a whopping 7,969 newtons of force. But we're still not done. Next we need to plug this information into the second equation to get the amount of force that the rocket itself is exerting on the soldier. Plugging all of this in, we get a whopping 8,852 newtons of force. There's no way a human would survive this, so if this were Mythbusters, this myth would be busted. But suppose there was something different about the soldier. What about him would make him not die? There are two possibilities I want to explore here. The first being that he is stretchy enough to be able to absorb the explosion and not be torn apart. Thanks to Mr. Lucchetti for this idea. While this is a very good idea, I don't think this is an accurate explanation, seeing as when he does rocket jump, his body remains the same and doesn't stretch. The second idea is that his skin is just extremely tough. Though, if that's the case, then Pyro must be incredibly strong in order to be able to cut off his hand. I don't think it's a perfect explanation, but it's the best one I got. Though I suppose that it doesn't really matter too much anyway, seeing as this is a hypothetical situation about an imaginary world. But it's fun to think about. Well, for me at least. Thank you so much for watching. I know this wasn't very professional, seeing as this is the first time I've ever done any video editing. but I had a lot of fun making this, and I hope it was at least somewhat entertaining. Thanks again to CDROM_Overwatch. Check out his Twitch down in the description. This is also a way for me to get him to stream more. Thanks to my physics teacher, Mr. Luchetti, for allowing me to do this project to make up for a missed lab. I hope this was a good substitute. That's all. You can go now.